hide that. So let me just change this a little bit so as it's a bit more out of the way. I think I'll move it up here. So we've got, these are the types of energy types these are the energy types that we can think about. All types of energy can be thought of and categorized into those types. They're all energy, and so they're all measured in something called joules. Okay, so we can say that all energy types are measured in joules. Okay, and the symbol for joule is capital J. So let's make that, and we'll highlight it green. So we've got kinetic energy. Anything that's moving has got kinetic energy. Chemical energy is the one that people usually forget, and that's when it and it's kind of weird. That's why. So if you imagine anything that releases energy using a chemical reaction, so if you burn something, if you burn some wood, there's a chemical reaction happening there, and you're producing heat and light. So therefore, the wood must have had chemical energy to start off with. The same with a battery. The battery releases chemical energy, and whenever we eat, food contains chemical energy, and that's how we use that. That's why we eat, because it has, well, the main reason why we eat, so as we can get the energy from them. We've got elastic energy, anything that is already stretched or already squashed, such as the spring on this mousetrap. As soon as it's released, then it can be turned into something like kinetic and thermal again, or probably sound as well. That would have elastic energy. If it's not stretched, it doesn't have elastic energy, even if it could be stretched. It only has elastic energy once you have stretched or squashed it. Thermal energy, anything that gives out any heat is giving out thermal energy. Thermal energy is heat. Electrical energy, this is just a way of transferring the energy from one thing to another. So if I plug in this light bulb into a battery, then there's going to be wires between the battery and the light bulb, and the thing that the stuff that is traveling along these wires can be called, if we're thinking about it, energy can be thought of as electrical energy. Gravitational energy. Gravitational is a type of potential energy as well. We'll talk about that in a moment. If anything is raised up high, then it's gained gravitational energy. And by the way, it's worth mentioning that once, let's imagine with my example, the book fell off the shelf, lands on the floor, and you go, oh, does that mean now it has no gravitational energy? Well, if you dug a hole and then pushed the book again, it would fall down the hole. So gravitational energy is kind of a weird one, because we don't really think of something having no gravitational energy or and so on. We think of it more as an increase or a decrease in gravitational energy. So when something is lifted up, it has an increased gravitational energy, and if something is dropped down, it has a decrease in gravitational energy. We've got light energy, otherwise known as electromagnetic energy. Like thermal energy, it's just released. It can't be contained or stored for later. The reason why it's called also electromagnetic energy is because light is just one type of electromagnetic wave. So there are other types, such as infrared, and we don't call that light because we can't see it, but it is there, just like light, it's there, and things give out thermal infrared energy. And the same with ultraviolet and radio waves and microwaves, all those kinds of things. So light energy is just a type of electromagnetic energy. Sound energy, something gives out sound, very similar to heat and light, basically. So it's giving out sound energy. Now, when you learn a bit more about sound, you realise, well, sound is nothing more than vibrations. So actually, sound energy can be thought of as a type of kinetic energy. And actually, to be honest, you can think about the same with thermal energy, but we'll not get sidetracked too much. The reason why we call sound energy a separate energy to kinetic energy is because if we say that an object has kinetic energy, that means the object itself is moving along from A to B. Whereas if the particles in the object are vibrating, we say the object has heat energy, is giving out heat energy, and it has heat energy. And if you can hear something, of course, we can say it has sound energy. Nuclear energy. If you learn a bit about nuclear fission, you'll know that some things have nuclear energy, and that can be used to convert into electrical energy at nuclear power plants. And then magnetic energy, I won't mention too much here, apart from that is another type of energy. So potential energy, some of these energies are potential, which means that they can be stored. So chemical, elastic, gravitational, and nuclear, I sort of explained. I didn't talk about how kinetic energy can be stored. We don't think of anything, if something's moving, we don't imagine that it's storing energy. And the reason being is because if I was driving along with my car, I have to keep putting petrol into it. And so it doesn't feel like it's storing energy. But that's because energy is being converted into thermal and sound all the time. As I'm driving along, there's friction between the car and the road, and there's air resistance, and that's producing thermal energy. And so, if there was no friction and no air resistance, I wouldn't need to put any energy into it. So, for example, a meteor flying through space has kinetic energy. It will carry on going forever and ever and ever until it hits something. And so you can think, therefore, that meteor has kinetic energy stored in it. And the same with anything else, it's just that usually it's transferred instantly into sound and heat. So what is an energy transfer? It's when one type of energy is transferred into any other types of energy. It could be one, two, or more types of energy. So this electrical motor is trying to make kinetic energy. It helplessly also makes thermal energy. It's not part of the plan, but it does. It uses electrical energy, so we can say that's the input energy. These two are the output energies. We say the one that it doesn't want to produce is called the wasted energy, and the one that it does want to produce is called the useful energy. So we have wasted and useful energy. We're going to talk about efficiency in a moment, but briefly, if something produces a lot of useful energy and not much wasted energy, we can say it's efficient. If it's the other way around, we say it's inefficient. If a motor doesn't produce much kinetic energy and produces a lot of thermal energy, then it's not very efficient. It would mean I have to put a lot of electrical energy in to get a small amount of movement energy out. So that's not very efficient. That's what we mean by that. So that's basically the overview for that. All right, for now. So I'll just stop that.